this video, I will try to explain energy levels and spectra. First of all, let's look at the structure of an atom. An atom has electrons, protons and neutrons. Protons and neutrons take place inside the nucleus and they have no motion. But electrons move around the nucleus in their orbits. In other words, they have circular motion in their shells. Also, electron shells contain a certain number of electrons. First shell must have maximum 2 electrons and second shell must have maximum 8 electrons and so on. For example, a helium atom has both electrons in the innermost shell, and a lithium atom has 2 electrons in the first shell and 1 in the second shell. At this moment, an interesting question comes to our mind. Do electrons go out of their shells? Answer to this question is yes. They can jump to the next shell or they can return to their own shell after they escape from it. Now we will see how electrons change their orbits. Again, we have nucleus containing protons and neutrons, and an electron is in the first orbit or in the ground state. Ground state is the lowest energy level state of electrons. If we give enough energy to electrons, it can jump to the next orbit or to the first excited state. This is also called excitation. For this electron, 4 electron volt must be absorbed to move to the first excited state. If it absorbs 6 electron volt, it moves from ground state to the second excited state. If it takes 1 more electron volt, it moves to the third excited state. So how can we give energy to the electrons? We can give energy by giving light or sending photons with energy levels. Photons with more energy can move electrons to higher excited state. We also mentioned that electrons can return to lower state. If an electron moves from higher state to lower state, it emits light or photon. So let's look at the energy level diagram for the mercury atom. We can see the lowest energy level 10 minus 10.4 electron volt. Excitation energy is shown in the left side and energy level is shown in the right side. At the top we see ionization. What does it mean, ionization? Ionization means that electrons absorb enough energy to escape from the atom. For mercury it is 10.4 electron volt. This amount of energy is enough to ionize the electron. Now we can calculate the energy of the emitted photon by this formula. Hf is equal to E1 minus E2. H is the Planck's constant, F is the frequency, and E1 is the energy level of higher state, and E2 is the energy level of lower state. And the difference between energy levels gives us the energy of the photon, Hf. Let's try to understand what happened with this atom by looking at the diagram. Initially it was in ground state and it absorbed 5.7 electron volt photon energy, so it jumped to the second excited state, and then it emitted 0.8 electron volt by de-exciting or jumping back to the first excited state. And finally it emitted 4.9 electron volt photon and came back to the initial ground state. Absorption spectrum. Absorption spectrum is also important in determining the kind of an atom. For example, in the container we have unknown atom. When we shine light on this atom, we will see the spectrum on the screen like this. There are some missing colors or missing wavelengths. It is because some photons are absorbed and electrons are excited to the higher states. So by looking at the spectrum we can find out the kind of an atom because it's like a fingerprint for an atom. This method is used in astronomy to know which elements are found in stars, in planets, and in universe. Emission spectrum. Emission spectrum is also a phenomenon. We also have emission spectrum in nature. This is the reverse action of absorption spectrum. In emission spectrum, only photons with certain energy levels are emitted when electrons are forced to de-excite. It occurs in neon light and in gas discharge tubes. Remember this formula: C is equal to F times lambda. C is the speed of light, F is the frequency, and lambda is the wavelength. We do some calculations in this example. A mercury atom de-excites from its 4.9 electron volt energy level to the ground state. Calculate the wavelength of the photon released. To calculate the wavelength, first we must find the frequency. Frequency formula is this: HF is equal to E1 minus E2. So this is the energy to find the photon. H is the Planck's constant, F is the frequency, and E1 minus E2 is the difference between energy levels. So E1 is 4.9 electron volt minus E2 is 0, so 4.9 electron volt. So we must change electron volt to joule. To convert electron volt to joule, we must multiply 4.9 by 1.6 times 10 to minus 19. So if we multiply it, 7.84 times 10 to minus 19 joule. Now Planck's constant is given 6.63 times 10 to minus 33 times frequency is equal to 784 10 to minus 19. From here we get frequency 1.12 times 10 to plus 15 hertz. So after we find frequency, we can calculate the wavelengths by this formula: C is equal to F times lambda. C is the speed of light, 3 times 10 to 8 is equal to 1.12 times 10 to 15 times lambda. From here, lambda is equal to 2.56 times 10 to minus 7 meter. So this is our answer: wavelength of the photon released. This is our question. So this is the end of the lesson.